All right, hey guys, we can get started. And so as you can see here, welcome to, oops, let me see, meeting is being recorded. Okay, so this is our session 2, databases and servers of Stackschool. And today the presenters are Kian, Lorelei, and me. My name is Xiu. So yeah, here are the links to slides and also link to Discord. And I've also just posted, the link to the slides to our Discord resources channel. So feel free to open it and yeah, take a look at what we're going to cover today. So also have some more links to slides, link to 2 GitHub repos. So just to clarify a little bit, the first link is to the completed demo, the demo that you guys, see the wonderful app that Sam and Sneha have already built last week. And as for the running demo, it's more like an incremental build for this app. And we are going to just upload what we coded in this session every time we conclude the session itself. All right, so just a review of the curriculum. Last week, we covered a little bit about, intro to full stack mobile development. This week, we're going to talk more about databases and servers, and there are 3 sessions left in this quarter to go. All right, so I guess the plan for today is just first, I will cover a very quick recap of what we did last time, just in case some of you weren't here last week, or if you just want to kind of just get a refresh on the content. And then I think Kian will cover a little bit about databases, and Lorelei will cover a bit more about servers. So this is me, and this you all. This is the master plan. I'm telling you, I'm dictating that this is the master plan. So quick recap. I think, in my opinion, last time we covered 3 very important concepts: mobile development, full stack, and Swift. I'm going to start with mobile development. What is mobile development? I think this term is actually quite self-explanatory. Basically, mobile development means to create software applications that run on mobile devices. So I think the majority of the devices right now are phones, tablets, smartwatches, but that range could expand in the future. There are 3 types of mobile apps in general: native apps, mobile web apps, and cross-platform or hybrid apps. So for this workshop, for this series, we're going to mainly focus on native apps. So what are native apps? Native apps are applications that's created for one specific platform or operating system, and they're installed directly on the mobile device itself. So I guess one characteristic of these native apps is that they're developed with platform-specific languages or tools. So for iOS, that means that your app is most likely going to be written in Objective-C or Swift. And for Android, your app is most likely going to be written in Java or Kotlin. So of course, we're going to write an iOS app and we're going to use Swift. All right, so that was mobile development. And then we can move on to our next concept. What is full stack? So I guess, okay, again, in my personal opinion, but if there's only one thing that you can take away from this entire workshop series, this has to be the concept. Please remember what full stack means. Don't make us cry. But of course, if you could, remember more stuff from our workshop series, that would be great. We'll appreciate a lot. So full stack is when you work on all parts of the app, both front end and back end. Front end is the buttons that you click, the colors that you see, and the pictures on a screen and stuff like that. So basically, front end is the part of the app that users see and interact with directly. On the other hand, backend manages data, performs computations, and interacts with databases. So you can't really see anything that's going on there, and you don't really interact with these stuff either. So I think last time Sneha gave us a good example of a TikTok app. Basically, the front end is, the reels that you see, the like button, the comments, and things like that. Whereas the backend could be, the databases that stores all those reels and, the recommendation algorithm that could push you the reel that you're most likely going to be interested in. Cool. So that was full stack. And I think our last kind of topic was Swift. And what is Swift? Swift is a programming language. So it's like something that you've learned before, like C++ or Java or JavaScript or Python. It's like any other programming language, except that it's used mostly for developing native apps, and it's maintained and supported by Apple. And we saw a lot of like syntaxes in Swift, like how to print statement, how to define a variable, how to assign a value to a variable, how to define a function, how to do an if statement, and stuff like that. On the other hand, we have Swift UI. Swift UI is not a language, so these are 2 separate things and 2 separate concepts. Instead, SwiftUI is a set of tools that defines and builds the design of the user interface. So luckily, we don't have to build everything from ground up. We don't have to rebuild the wheels again and again because Apple provides a set of tools that makes us work on the UI a lot simpler. So we also saw a lot of syntaxes, how to display a line of text, how to display an image, how to have a button, like vertical stack, horizontal stack, stuff like that. So yeah, I wouldn't imagine that it can be kind of overwhelming to see all these syntaxes, in one place at one time. But if you are not feeling comfortable with some of the concepts that I just mentioned, I would recommend reviewing the slides and recording from last session, and they're all available in the resources channel on Discord. So yeah, does anyone have any question about what I just said? I know it was a very quick recap in less than 6 minutes. So if there are any questions, now is the time. If not, okay, we can move on to the next topic then. It was a lot for a quick recap, and the good news or the bad news, depending on how you think about it, is that we need more than what we have learned in the last session. Because now that we have a user interface that can display content, we also want it to show actual data from our database. Basically, if we're building our Brewing Eats app, we want it to show actual data, like actual restaurant data, actual review data that's stored in our database, and that will require more knowledge in that aspect. And I think Kian from now on is going to talk a little bit about databases, and I will see you guys in a bit when it comes to setting up the MongoDB.
Okay. Hello, everyone. Now we're moving from the recap, kind of going into new material. I'm going to start with what are databases. Databases are essentially just a structured set of data and they make it easy to store, access, and manage that data. Now, if you don't know what that really means or why you'd use it, don't worry, I'll elaborate. Imagine after we finish our Brew and Eats project, you fall so in love with the idea of restaurants that you decide to open a restaurant of your own. But then you realize you do have to take note of some information, whether it's like what people order, how much it costs, what time they order things. So you tell your cashiers just to write it down wherever they want. And they end up writing it down on sticky notes, and it would look something like that. It'd be like Bob ordered cheeseburger, it cost $7. I think John ordered French fries and it cost $5, and Dan paid $3 for a shake. After some time, you realize this is probably not the way to go. It's really inefficient, it's not scalable, and there are concurrency problems. All that means is some problems arise when more than one person's accessing or storing data. So like if you have more than one cashier, they might be putting the sticky notes in different places, and that just makes it a lot harder for the chefs. So instead, you tell your employees to store the order information on a bulletin board that's systematically organized, it's easily searchable, and it's accessible to all the employees. And that would look something like this. That's a lot better, right? Now you're probably thinking, okay, that's great, but why do I need to know this? I'm probably not opening a restaurant anytime soon. This is a great analogy for why we use databases. So instead of storing the files either on your computer or on your memory, you upload them to a database where anyone can access them. Anyone working on the project can access them through like a structured way, and they're all systematically organized. Okay, now you know a database, again, a structured set of data, and then it stores information in a way that's easy to store, access, and manage. Okay, now that you kind of know what databases are, I'm going to be going over the two types of databases that exist. These are relational and non-relational databases. We're going to start with relational databases. They're written in the SQL language, which you can see here. Don't worry, we're not going to have to learn that. And they're stored in this sort of relational table format where there's different tables that store different types of information, but they're all kind of connected through the one ID variable. Can anyone tell me, just using these related tables, like what would be one order? Or specifically, what is the first order by Bob Smith? Can anyone tell? Or what they order, what time was it, and how much did it cost? Does anyone have an idea? Or either I don't know, some food.
You ordered a burger, 50. That's funny.
Perfect. Do you want, I don't know, do you want?
I didn't do five.
Okay. You can come up after maybe. Okay. Okay, yeah. With that being said, there are some cons to relational databases. They're pretty complex to set up and manage. You do have to know the SQL language that I showed you guys earlier, and they're usually slower and more costly than other alternatives. And for those reasons, we're not going to be using the SQL language in our project. Instead, we're not going to be using relational databases. We are going to be using non-relational databases, which come in all shapes and sizes outside of the related table format. And these include key values, column family, graph, and document. But for the purpose of our project, we're only going to be focusing on one, and that's document, because the database we'll be using, MongoDB, uses the document type database. So what is a document type database? Document type databases are essentially just a database broken down into collections of documents, and I'll explain what that looks like in a second. And the good thing is we don't have to use the dreaded SQL language that I showed you guys earlier. Instead, we're going to be writing it in JSON or JavaScript object notation. And what that looks like is a document of key value pairs. Key value pairs, essentially, the key specifies what the data is, or like what it is, and the value is the data itself. So an example of what that might look like is name, Dan, food shake, and price $3. And then we could use the same structure for more than one document and have a collection of documents that store, for example, order data. Okay. And that, yeah, these non-relational databases, they're more flexible than relational ones. They're easier to learn and set up because you can see how much easier that is than SQL. And they're usually faster and cheaper. Okay, that's all great, but how am I going to be using databases in my project is probably what you're thinking. So just as a waiter in your restaurant might want to use the bulletin board to store and access information when, for example, a new order is made, or to find out who ordered that and for what cost, you as an iOS developer would want to use the database to store and access information having to do with accounts. For example, when an account is created and a user is signing in and you want to authenticate whether it's really them. Another example could be when people comment on your restaurant, you want to store the database or store the comment to your database, and you want to access it from the database whenever you want to display it to other users. Okay, I think that's all for databases. I hope you guys have a general understanding of what they do. If you guys have any questions. That's perfect. Now we're going to set up MongoDB on your guys' computers, hopefully.
Okay, thanks, Keon. So now that we know what databases are, we're going to actually set up the database that we're going to need for our app. So MongoDB is the database that we'll be using. And in order to, do all the steps that comes after it, go to this website and yeah, just register an account and log into your account. So I already have an account, so I don't really, I'm not going to register an account just for this purpose. I'm just going to sign in. But yeah, sign with my email and password and log in. Okay. So I think I'm just going to divide this into two screens. So that's better to display. Okay. Right. So assuming now that you all have an account already, the next step will be to create a new project. So to do that, I want to actually first delete my current project because I had to prepare for this workshop and I have done the setup already. So I already have like a Brewing Eats app project over here, but maybe I would want to, actually, I'm just going to create a new one instead of deleting the current one. So I'm going to have a new project, open project, and I want to name it probably not Brewing Eats app because I already have one called Brewing Eats app. I'll just say Brewing Eats app demo. Okay, so Brewing Eats app demo, and you can just omit the tags. They're not needed for our purposes. You might need those if you're in a production area, like you're working in a company that might require you to add some tags, but click on next. And you don't have to change anything here. The email that you're logged into should be the project owner. And yeah, you're not able to change it anyways. So after setting these up, you can hit on create project and a project should be created. Takes a while and it worked. Sounds good. So here's a project that we've created, but we don't really have anything in here. And honestly, we can't do anything with it because we still have one more step. That is to create a new cluster for our app. So yeah, this is just some steps that I've gone through. After we have created a project, you can go ahead and click on create a cluster, the create button over here. Hit on create. And there are a lot of, configurations that we need to kind of just set on our own. So the first one would be, the tier. Of course, we're going for the free tier, unless you're quite experimental and you don't really mind, like spending a few bucks. Then you could, go for the M10 or serverless option. But we would just go for the M0 option, and it's sufficient for our purposes, I would say. But yeah, go for M0. And for configurations, you can change the name. I'm not going to change the name because I can't think of a good name as of right now. So I'm just going to leave it like that, like cluster 0. And the provider, you don't have to change it. The region, you don't have to change it. Just, stay as recommended. Tags, you can omit them. And yeah, I think just keep everything else default, and I can create. All right. So there are more configurations that we need to set up. So the first one is add a connection IP address. I have already set this up, but I have included some instructions in a slide. So if you haven't set up a connection IP address, you'll be given these 3 options called add your current IP address, add a different IP address, and allow access from anywhere. So my recommendation would just be to allow access from anywhere because it will be easier. It's the easiest option. You don't have to worry about, sometimes I can get sometimes I can get access, sometimes I can't. Whereas the other 2 options are more for security purposes. For example, if you're like building an actual software and you want this software to be only usable by the people who's kind of just logged in to the same network as you are, like, everyone in your company can use this app and no one else can. In that case, maybe you want to restrict on the IP address that connects your database, but for our purpose, not really, right? So you can just allow access from anywhere. So I've set it up already. So you can see that, like I have a check mark over here indicating that, I have already set it up. And the next thing that we have to do is to create a database user. I would say this is one of the most important steps in this setup because we would actually need some information from this step later on when we're trying to code our project. So the username, you don't really have to change it. You could change it though. I might change it. Okay, I'm just going to change it to admin. So that it's more, distinguishable and more readable. People can just tell that this is the admin of the app. And for the password, I'm changing it to something that's more, I guess, also more readable and something that I can actually like remember, not this string of whatever. I'm just going to change it to hack is awesome. Okay, and remember to copy your password, or if you're confident enough about your memory, you can just like try to memorize it, but I'm not, so I just copied it. And then you can hit on create database user. And so yeah, we have done both of the steps and we can choose a connection method. All right, so you don't really have to do anything on this page and you can close this because we'll be getting our connection string from somewhere else. And you can just close it and you're done with the setup. So yeah, this is just some instructions on what I just did. In case you missed anything, just follow this and save your password, save your password, save your password. Or else you would probably need to create another database user. It's going to be a lot of trouble. All right, so I think the next step is just to get our connection string. So that's something that we're going to be using in our project repository. So to do that, scroll down and you'll be able to see this drop-down menu. And you can select the programming language that you're coding in. We're using Swift, so just go for Swift. And then we can get the connection string by clicking on this button. And the connection string is over here. But don't just directly use the string, because if you look at it carefully enough, this string is composed of several parts. The first one is just this kind of just prefix, and this one is my username, followed by a column, and then followed by this DB password. So this DB password is just the password that I just asked you guys to save. So in my case, it would just be admin : hack is awesome. And add cluster, some information about your cluster and some random information about your app and stuff like that. So in order to actually get your real connection string, you would have to replace this square bracket DB password with the password that I asked you guys to save 2 slides ago. And I guess just as a reminder, don't keep the angle brackets. So I think the first time I developed with MongoDB, I actually like, put the brackets, left the brackets there, and it just didn't work. And I was so confused. I spent on like probably 30 minutes debugging it. And I was like, ain't no way this is not going to work. And then I checked my connection string, and then wow, it was because of me not removing the brackets. So just remember to remove the brackets. And after you have done this replacement, just save your connection string somewhere. Maybe write it down on a piece of paper, copy it and paste it into your notes or something like that. So yeah, I think that's actually it for our setup. And we have a 5-minute checkpoint for you guys to all work on like the setup, and you guys can ask questions, or if you guys are running into any sort of problems, Hack Officer will be there to help you out. Okay, so is anyone following along on this setup procedure? And if you are, like, which step are you guys at? Question mark? Okay. Should I assume that no one is following? I don't think that's a good assumption to make. Okay, have you guys finished? Oh, nice, nice. Any troubles, any problems? Okay, sounds good. Okay. Okay, in that case, maybe we can just start again in 2 minutes instead, since this is not taking as long as I would think. Okay, yeah, sure. What's up? Yeah. We're not.
That's great project.
Yeah. Yeah.
There's like some map. Or do I have to do?
You can't really edit the website one.
Yeah. Yeah.
There's like, wait, there's other things too. Yeah, I
Just
know.
skip them.
If you want, you can come, up to you.
Maybe that's just.
Oh, I didn't know you were talking that. Okay, we can continue. And yeah, so that would be all for the databases part for today. And Lorelai is going to talk a little bit more about servers.
Hey, hi everyone. My name is Lorelai, and I'm going to be talking a little bit about servers. So, here's a little roadmap of what we're going to talk about. We're going to answer some questions first. So, what is a server? How do they work? What is an API? And finally, what is the difference between servers and APIs? So, let's get started. Okay, but before we get into the nitty-gritty and all the seriousness, I have to ask you guys a really important question. What do all of these things have in common? Somebody can raise your hand, you can get a prize. Okay, I'll do, actually you both have glasses and you're both wearing a hood. You're not making this easy for me. Okay, the person in the front.
They're serving.
Yes, you're so right. They all serve. Okay, but in all seriousness, what is a server in the context of computer science? So, can anybody, you've probably, if you're involved in computer science, have heard of a server, or maybe you already know what it does. Can anybody raise their hand and tell me what a server is? Also for a prize that you can get at the end. All right, if no one wants to share, good news. You can look it up on Wikipedia and it will give you a really long answer. Wikipedia is going to tell you that it's a computer that provides information to other computers called clients. It goes into detail about the different types of programs, client and server programs, what it does, the different types of servers. But here's the thing. We're not in computer science lecture, so we're not going to go through all the nitty-gritties of this. You're not going to get tested on it. We're here because we're trying to make computer science exciting. So, what is a server, the fun version? Digestively speaking, it's like a super-powered vending machine. A server is a powerful computer that can store and send information when you want it. So like a vending machine for the internet, you can process a request and it'll give you what you want. So for example, if you're working on a website and you want a video or you want some information, a server is what is going to give you that information. So why do we need servers? So as you probably already know, if you're familiar with front-end and back-end components, there are two aspects of web design, which is front-end and back-end. They're both really cool in their own respects. For the front end, you can have a user interface, you can make really cool buttons and have animations, and the user can have a lot of fun. And then for back-end, there's also databases, which Keon just covered, where you can store all of that information. And both of them are super cool on their own. But in order for them to work together, we need to have something called a server. So yeah, they can't operate or interact on their own because front end is what the user is going to see and back end is pretty much what we're going to code. So servers help you interact with the two of them. So now that we know what servers are generally, let's talk about how they work. So the server has three primary functions for our purposes. That is going to be store, process, and deliver. So going back to our vending machine analogy, let's say that this vending machine is our server. You can store data in it. So for example, let's take this soda can as our data. Once you have a server, you can store information there. And then to process it, let's say you want a soda, you can send a request to the server and the server is going to process that request. And then finally, once this process has been completed, it's going to deliver, aka it's going to send out a response or that soda. And then you can go and do whatever you want with it. So just a couple vocab terms. We've got the server, the data, the client, the request, the process, and the response. Does anybody have any questions at this point? Pretty clear? Okay. All right, so we just talked about these, so I'm going to skip over this so that you have more time for the demo. So now that we've talked about servers, another important thing we need to talk about is an API. All right, for a treat, squishy, or prize, can anybody tell me what API stands for? Yes?
Application programming.
Yes, ding, 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 that's exactly correct. Okay, application programming interface. That's absolutely correct. So we've just talked about servers. APIs are very similar in the fact that they act as a connection between front end and back end. So it is a messenger or a translator that allows different software applications to communicate with each other. They can exchange data through programs that we call APIs. It provides a set of rules and protocols for how a piece of software can either request information or perform actions on another system. So that might be a little confusing on first glance. So let's go back to our vending machine analogy. So let's say you're the client again, but for some reason you're too lazy to go get your drink from the vending machine. Like it's too far or like you've got homework. So you can actually enlist the help of an API. Let's say that that's your friend. Now, when you want something, you're going to form a request and you're going to give it to the API or your friend. And then your friend is going to take that request and they're going to bring it over to the server. They're going to put the request into the server. The server's going to process it. And it's going to turn around, it's going to get the response, the data that you wanted, and it's going to get it right back to you. And then once you get that data, you're free to do whatever you want with it. I hope you guys like my animations. I spent a lot of time on them. So yeah, oh, thank you. Okay, so that's basically what an API does. It's sort of like the middleman that allows databases and servers, as well as the front end and the software to communicate. So clients and servers can communicate through APIs. So now that we've talked about servers and APIs, what's the difference? I know that when I first learned about this, it was kind of confusing because they both act as connections between front end and back end. But simply put, a server is a computer. It's the machine where you host your program. It's going to store and process that data. And in our analogy, it's the vending machine. An API, on the other hand, is a program. That's going to be the software. That's the thing that you code. It's an interface. So it's going to set the rules for how different software systems can communicate, and it's going to provide a way for those apps to request data and then facilitate that communication between the systems and the apps. So yeah, that's pretty much the end of my section. I hope you understand what servers and APIs are. And then more demos.
Okay, so thanks Lorelai for covering servers. And I think the next demo is just going to be connecting the MongoDB the MongoDB cluster that we just set up to our application. So I guess just to reiterate kind of from something from last session, make sure you have Vapor installed. So I guess just to clarify a bit on what Vapor is, it's different from Swift UI. Swift UI is for creating the app's user interface, like everything you see, every button you click, every text, image, so on and so forth. Whereas Vapor is a set of tools that lets us write the backend of our application using the same Swift language. So it can handle tasks like, storing data, process requests, and managing the app's logic. So there are other frameworks that could let you write the backend in other programming languages. But since, we don't really want to learn too many languages in one go, we're just, using Swift for both front end and backend. So in order to kind of just set up for Vapor, these are also just commands that we have mentioned during the last session. So if you weren't here, probably just try to follow along and set up for the next steps. But some of the steps that's needed is over here. Actually, I am just going to rerun all these so that I can have a new project over here. Okay, this is not the terminal that I want. I want a new terminal. Okay. Okay, let me. Okay, so, okay, rearranging this. So the first one is just to brew install Vapor. I have installed Vapor already, so I'm not going to run that one, but I'm going to run all the following commands. So I'm going to start with changing my current directory to downloads folder. You can also just not change it, but it will just be in your root folder. I guess download folder is just easily to locate and easier to find. So I just changed my directory to that. And then I will create a new project with this vapor new -n command. So I think last time, if you followed along, your project is most likely going to be called something called Brewing Eats. But for now, I'm going to use a new name just because it fits better with our topic for today. Our topic today is backend, basically. So basically, Vapor new backend -n. So if you're wondering what -n means, that basically means answering no to all the options. So if you don't have that -n, you will be asked like a lot of questions about if you want to have this installed, if you want to have that, added functionality. We want a simplest app, so we are going to say no to all of these options. So yeah, just taking a bit, and you should see this very interesting logo over here if everything is working correctly. So yeah, now that I have it, I'll move on to the next step, cd backend. That basically just means that I'll change my directory to the folder, to the project that I just created. So cd backend. And there is one final command that I need to run. It's called open package Swift. So this open is not a verb, or I mean, it is a verb, but it is part of the command. You're not opening any file, you're typing in that open into your terminal. So I'm going to say open package.swift. Oh, well. Well, okay, so if everything goes well, there should be an Xcode window popping up. Hopefully y'all can see it. Let me just, how can I zoom in? Okay, maybe I cannot zoom in until I'm in the coding section. Okay, now it's okay. But yeah, so you can see here on the left, there are a lot of packages being installed as I was trying to figure out how to zoom in. But yeah, you should have all of these set up and all of these tools, they just appear like magic. But this is just what Vapor did. Vapor did a lot of the heavy lifting for us. So yeah, I don't need this, I think. I'm just gonna, yeah. Okay. So this is just running the commands that we that you guys probably or might have run last time, but for our new commands, you can click the play button and run our project, and it should take a while. I think it took me a while last time. Yeah, it's building. Okay, wait, this is slow. This is awkward. Meanwhile, does anyone have any questions about everything that I just, talked about, or is running into any sort of trouble into setting up this kind of template? No? Good. Man. Okay. Okay, Bill succeeded. Nice. And I think I'm gonna pull up the terminal. So yeah, now if you pull up the terminal, basically just drag this thing up, you will see that there's a notice saying that server started on this like address, and we copy this address and we go to a new window and it works. So yeah, it's just wonderful. Like we basically did nothing. We just typed in a bunch of commands and we actually have a browser working. So congratulations on creating, building, and running your first server and your first Vapor project. Of course, we didn't really do that much. Vapor did most of the stuff for us, but none of them are things that we have to worry about, at least as of right now. So just take that as your own effort, and you can brag to your cousins or stuff like that about it, saying that you built a server in 2 minutes. So yeah, now we're going to use more technologies. One of them is called Fluent. So Fluent is a tool that makes it easier for us to work with databases in a Swift app, especially when we're using Vapor. So they collaborate well together. So I guess just as an analogy, imagine there is a library catalog and you have to find something. So instead of having to go through every single entry, instead of manually inspecting every single entry, Fluent is like this very professional librarian who could get your book, and they really exactly know where the book is. So yeah, I guess just as a overview, or just as a general view, the way that Swift UI and Vapor and Fluent, they work together in a UI in an app is like follows. So first, your Swift UI app will kind of just interact with a server that is built by Vapor. And the Vapor will process the requests that came in from your Swift UI app. Like, for example, there's a user trying to log in, and your app will just send a request that says, okay, here's a user. I would like to authenticate if they're a registered user in our database. So after that, Fluent will help the Vapor store and retrieve data from database, which in our case is MongoDB. So in the example that I just gave, maybe here Fluent will just help Vapor determine if this user, their password and their username is already in our database and is correctly, like entered or something like that. And finally, after Fluent retrieves that data, they will send the data back to your Swift UI app, and the data is displayed to the user. So actually, this is more like a loop rather than like a linear set of steps, but the loop graphics is just a bit weird, so I didn't try to use it. Yeah, but this is like, the general workflow of how your app will send a request, and, your server will kind of try to deal with that request, and your database will also try to deal with this request, and the results will be sent back to your app. Okay, this is kind of confusing. Does anyone have any questions about, what Fluent does? What are these like technologies like Vapor and Fluent and Swift UI and stuff like that, and how they work together? No? Okay. Sounds good. So I guess just as another example, say we're not building Brewing Eats, say we're building a to-do app instead. Swift UI will be responsible for displaying all these tasks. Also, maybe there will be a button that allow you to add tasks, whereas Vapor will be handling all the requests to send, to create, to read, update, and delete those tasks. And finally, Fluent will be responsible for storing these tasks in the database, and also maybe, retrieving the data if needed. So yeah, hope that was clear. And now we're actually gonna do some coding. So in order to connect our database, connect our server to our app, we actually need to add some code to our template folder over here. So I'm actually going to, hide this. And I think the first step that we will need to do is to add some code to our configure file. So to do that, go to sources, app, expand it. And over here, there is a configure file. So now this is just empty because we haven't really set up any configurations. Because if you remember, I said, -n means we don't really want any added functionality. We don't really want any added configurations. So that's why this is empty right now. But we now need to add something more. So something that we need is these. So we need import statements to tell our project that, we're using the technology called Fluent. We're using the technology Fluent to connect to a MongoDB database. So we need to import Fluent and this Fluent Mongo driver. So I'm just going to type it out because it's kind of hard for me to copy from a slide. But if you guys are on your own laptop, you can feel free to just, copy paste the code. I think it will be much easier. So I'll just type it out. Fluent and also import Fluent Mongo driver. Hope I got that right. Okay, seems right. Okay, no such module Fluent. Okay, I did not get it last time. Interesting. Let me just finish the configuration here and hopefully it will try. So yeah, I think after the import, we also need to just tell our app or our project that we're using the MongoDB with such connection string that we saved from a long time ago. But here I'm just going to add this on top of here. And it's going to be this try app database use connection string. So try app databases. Connection string, and the connection string will be from the MongoDB project that we created, like over here. So going to add it. I have to replace the password. If I remember correctly, my password was hack is awesome. Okay, so after that, a little bit. Looks right. I think I might have forgot to install Fluent or something similar, but let me just try to see. Oh, I think it turns out that I don't really need to import Fluent here. Okay. Never mind. Okay, I think I'll just gonna figure out what's wrong later because I think it just might be because for this new project I haven't installed Fluent. But if everything goes right, as you can see from this screenshot, there shouldn't be an error and there should just be these two parts that we added afterwards. We added on top of our template. So the first import part and the second database use part. All right. So I can figure this out later and let you guys know. Okay, so that will be the first step. And we also have to change something else. So to do that, we'll go to this file called package.swift. It should be right under your parent directory, like your backend folder, if your folder is called backend, and Brewing Eats, if your project is called Brewing Eats. But just go to that file, and there are a lot of configurations here that we need for our project, but you don't really need to understand what they're about. We will just add 2 lines to this file. One line is this package URL, basically saying that we're using this Fluent Mongo driver, and another line that says that we're specifying this product that we're using, and they're going to be added to 2 separate locations. So the first kind of line will just be added below this existing package line over here, and I think it'd be the best for me to just copy paste it because yeah, it's kind of hard. Okay, I see JWIC's highlight, but okay. Okay, just copy paste this. Oh. And also this code is added under the list of products over here. So line 22, if you're in the same format as I am, but maybe not. So around this line. So products over here. And yeah, that will be it for all of our changes that's needed for this file. And I think that will be it for the code that we need to add. So yeah, I think just as another checkpoint, try to incorporate the changes that I have mentioned. And meanwhile, I think I'm just gonna search up why is there an error with my import fluent statement. I checked, it's still not. Yeah, I think I just need to do some more downloading or something. Hmm?
Yeah, like,
Mm-hmm.
just copy the fluent Mongo driver, not get one, and change it to just fluent.
Okay. That's weird because I think the one that I had before this workshop, it worked without me adding that line. Yeah, I think it was really weird. Like this one?
Fluent dot get.
Okay.
Oh, like, yeah, well, dot get after.
Oh, wait, yeah.
Version should be zero. And then also under products as well.
Okay, that's definitely not in the documentation. I think I was following documentation and
Oh,
I think they just did not say no to all the options. They just added fluent in the very beginning. So they kind of just stepped. I don't know why my project worked then. Never mind. Okay. So product name, was it
yeah, just
fluent? Okay. All right, let's see. Oh. Maybe let's restart. Oh. Okay, I think the error has gone away, question mark. Okay, so seems like except from the imports, like the two statements that I have, asked you guys to add on the slides, we also need to import the Fluent product and also the Fluent package. Thanks, Sam. I would not know that was the case if you didn't say it. Anyways, okay, I think is anyone else running into any sort of like other problems with this setup, like seeing any errors or any problems? Okay, that's good. Seems like I'm the only one who's running into troubles. I love it. Okay, so that was, I guess, not 5 minutes, but I have trust in you all, so I'll just have that as our 5-minute checkpoint. But yeah, I think we're done with code for now. We will have more code coming up, very unfortunately, but for now, relax. We're going to cover more concepts. So yeah, I guess the last topic of today is to build models. So what are models? Apparently we're CS majors, that's not our models. No. So models are like blueprints for the data that our app works with. So they define what kind of data exists and how it's structured. So it's like, like a plan that you draw on the paper or in your laptop before you actually start constructing your like building or whatever. So if we want to build our own social media app before actually start coding, before actually getting like, starting to do work, we will need to define what makes up, like a crucial part of our app, which is a post. So looking at this post over here, there are a couple of, I guess, components that we can find that composes a post. So for example, the first one is a user ID, of course, the user who posted the post. And there are also, the content of the post and the image URL, if there is an image, and also a like count. This is a very simple model. So like, there are no like comments or links or anything like that. It's just these four attributes. And there is a type that corresponds to each attribute. For example, user ID will be of type UUID. What that is it stands for universally unique identifier, and it's pretty self-explanatory. It's a 128-bit alphanumeric string that's used to identify a object. So even if you have, 10 million posts, just by looking at their UUID, you'll be able to tell one post from all of the other posts. So it's like a unique identifier. And also for the post content, the type will be, string. I can't imagine it to be anything else, honestly. For the image URL, it's almost always string also, I think. For like count, maybe it will be integer, or if our app is really popular and the integer range is not enough for us, we would want to use something like, like a big int, but for our app, for this example, we'll just be using integers. So I guess just as, like a reminder or a quick or like a technical detail, when we define a model, we don't actually create an object. So when we, like set up this set of rules for a post, we have not created a post itself. It's a abstract set of rules that we have defined that specifies, what properties each piece of data has and which type each property is of. And it's not until that we populate our database with real data that those real objects are being constructed, and those real objects must conform to this sort of blueprint. So we can't have like a post with like count is a string, or like count is a UID that will not be conforming to our blueprint, and there should be an error showing up if we're trying to create an object of that sort of attributes. So I guess just as a question, in our Bring Needs app, what properties might a restaurant object have? Does anyone have any idea? Every restaurant has a name. Every restaurant has a. Okay. Do we all know what a restaurant is? Have we all seen a restaurant on a website or in an app? Yeah, not you. Okay, please. We have prizes. Okay. Okay, Kion. Ours said it's open. And Sebastian? Okay, I said a name, but okay, that counts. It can have two names too. Go ahead. An address? Sounds right. Rating. Okay, that's the only thing that I actually have prepared in my slides, actually, if you have looked at it. That's nice. Okay. Do you have anything else yet? Price category. Okay, nice. Yeah, I did not think about it. I probably should have. Anyways, those were all great, answers. Yeah, but yeah, like this is just a very simple model again. Like it's not any similar to the real world scenario. For our app, in our like kind of restaurant model, we have an ID that uniquely identifies every restaurant. So two restaurants, they might have the same name, they might have the same rating, they might have the same address, question mark, but they all have the different ID. Like just by taking an ID, you'll be able to tell the difference between one restaurant with all the other restaurants in the database. And also a restaurant, it better has a name, and maybe it will also have like an image on the website so that, like the customers can look at how the inner look like and how the dishes look like. So an image URL and also the average rating, as Lorelai said. And is there anyone who can tell me, what type these attributes could have, or like, does it make sense for these attributes to have? No, no. Go ahead. The ID. Mm-hmm. And int. Yeah, that could be. Yeah, I was thinking about a double, but a float would definitely work. Probably an int would probably also work, but it would just make a little less sense than like a floating point or like a double, because like when we're calculating average, there is almost always like something that's behind the point. Anyways, so yeah, exactly as you said, the ID we want to use UID and the name string, image URL string, average rating double. So yeah, so we have basically constructed the blueprint for our restaurant objects in our application. So now is the time to code it. All right, so the way that we define a model in Swift UI is through coding. So to do that, actually before we start coding, we want to have a place that stores all of our models. We don't really want them to scatter, like everywhere in our project repository. It'll be really hard for us to find it and to organize it. So what we're gonna do is we are going to create a new folder under sources app. So I'm going to do that right now. Where's my Swift? Okay, it's here. Okay, so sources app. So the way that you create a new folder in Swift or in Xcode is you right click on a folder and you create a new folder, and let's just name it to models. Oh, models. Okay, so models. And again, we will want to have a empty file that stores our restaurant model specifically. So we will again try to right click on the models folder and create a new empty file called restaurant. Yeah, so these are basically just some written instructions in case you missed. And yeah, so I think the first step that we will want to do is to, again, do some import statements. Import statements are always important, no matter what type of project you're trying to code, no matter what language you're trying to code in. So yeah, I guess just the three import statements that we need here is this import foundation, import vapor, import fluent. So I guess fluent and vapor, we have mentioned those before, but for foundation, don't really care too much about what that means right now. Just yeah, just do the import and it will work. So yeah, I think import foundation. Oh, shouldn't have done that. Foundation, import. So now that we have done our imports, it's time for us to actually, write some model code. So the classic syntax for defining a model in Swift UI or Vapor looks like something like this. So this is the very first line, defining a class. So it's called final class restaurant model. So you could use something that doesn't start with the final. You can just say class restaurant model. But with the final keyword, it would the compiler will optimize our code for us and make our code more efficient. So it's more recommended to add that keyword final. So yeah, I think the syntax is just final class restaurant. And the restaurant will be a model. And that will be our first line. And we'll wrap everything else with a pair of curly brackets. Okay, so now we're ready to actually define, the content or how this restaurant is set up. The first thing that we would do is to have this line called static let schema equals to restaurants. So basically, this is not defining the model itself. It's telling the database or telling Fluent which table that the model corresponds to. For example, maybe in my MongoDB database, there is a table called restaurants that stores all of our restaurant information. So this is the place that I kind of just clarify here that, this model is for that database table. On the other hand, maybe for user model, I would specify, the schema is users so that, the compiler would know that this model corresponds to that table. So yeah, just static let schema equals to restaurant. And as for the naming convention, it's more common to use single form in the class declaration. And for the schema, for the table name, it's more kind of common to use a plural form. So, but actually you can just define it using whatever name that you are that you find interesting. Maybe for the restaurant model, I could save all the information in a users table, but you would know that's not the most ideal setup. It's kind of confusing. It's very confusing. Okay, so now we have done everything that we need. We are moving on to actually, deciding the attributes that's stored in this model. So the first thing is the unique identifier. This is required. It's again a value that we can use to uniquely identify one entry from maybe thousands of hundreds of thousands of entries in a database. And specifically, you would like to tell the compiler that this is the unique identifier by using the @ID property wrapper. So the @id property wrapper, what property wrapper is it's like an annotation that specifies how a property's value is stored, retrieved, or modified. For example, the @id property wrapper basically means that, this is unique. I'm telling you it is unique. It can't be duplicate. This is the rule. This is the annotation. This is the suggestion that I am giving you as the programmer. And the other projects or the other property wrappers are not like this. They could have duplicate, their like field or something like that. We'll cover more later. But for the ID, here we have the @id, and the key is .id. Just use this as it is. And then we define a variable called var ID, and the type is UUID, like I said. So yeah, I think the okay. So moving on, after we have defined our unique identifier, we want to define more fields. Like we said, aside from the ID, our restaurant also has a name. A name is like a field, and you can have however many fields you want in a model to store these additional information like the name or the image URL or stuff like that. And they will be using the @field property wrapper. So right here, it will be something like, @field. Maybe I should zoom in a bit more. Okay. He will be name. And we define a variable called name. And the type of this variable is a string, like we said. Okay. And that is, one of the properties that we have. We can have more. Like, we said that image URL is also a string, so I can just copy this over. It is also a field, but the key will be different. And our name, our image URL is a string. And we can have, I think, one more. Like we said, each restaurant will have a rating. So average rating. And over here is the type will be a double. All right, so I guess that will be the most simplest model. And I'm just going to stop there. You can explore more property wrappers or more attributes if you want to after this session. But we will move on. And after we have defined all the ID and also the fields of this model, we can we can create a new and empty restaurant by using this line called init square bracket, curly bracket. So if you're familiar with some other programming languages like Python, maybe you would find some syntaxes like this familiar, but if you're not, don't worry, just code it as it is and it will work. Yeah, I'll just say init and the curly bracket. Okay. And then finally, we want to create a new restaurant with all these properties set using this init function that we just or not using this init function. It has the same name with the previous init function, but we have more arguments passed in so that, like when we call this function, it will just create an object of these argument values. So for example, this function over here, if we call it, it will just create an object that's totally empty, that has nothing, that has no value set up. Whereas if we call this object, this function instead, and passing all these arguments, we would have a restaurant object that has the ID set as the UUID that we passing here and the name that we passing here. So I guess here, pass in ID, type of UUID. And we will initially pass in this UID with nil because maybe when we're trying to call a function, we don't really know what UID we're going to use. So that's a default value, but for the name, we better know what name this restaurant is called when we kind of just trying to create this object. So name is a string, and what else we have? We have image URL is also a string. And what else? Yeah, we also have a average rating. And that is of type double. Okay, so after that, in the function body, we're basically just trying to bind all these arguments that we pass in with the attributes of the object. So we're using the self syntax. And again, if you have experience programming in Python, you might find this familiar, but if not, don't worry, it really doesn't really matter. So what we have to do is just to say self.id equals to the value of the parameter that we passed in, ID, and basically repeat this for every single argument that we have. Okay, that's actually it for the model definition for this restaurant type. And as you may know, we also have other types or other models that we need in our Brewing Aids app that will include, like a comment or a review, and also like end user. And they all have, different attributes. For example, end user, they might have their username, user ID, profile picture, and all the comments that they have posted. Whereas a comment might have attributes like, the time that they're posted, the content that the comment include, and also maybe rating or stuff like that. And I encourage you guys to explore all these like definitions and possibilities of these models. So yeah, create your own models for reviews and users. And I think this is the last slide of this session. Do you guys have any questions about, what a model is and how to use them or define them? Go ahead.
That ID part.
At ID part, what does it say specifically?
Property ID sendable supporting class.
Yeah, okay, I also got that when I was writing this and I searched it up. I don't think it's a breaking error. And if I try to just figure it out, it will be much out of the scope for this session. So I think you can leave it like that as of right now. And if you run into any sort of like blocking or breaking issues, let us know and we'll try to figure something out.
Okay.
Yeah, so basically the warning says stored property ID of sendable conforming class restaurant is mutable. This basically means is there is a possible threat when you are trying to have multiple threads. So when you're trying to have multiple clients that's trying to like modify the same restaurant object at the same time, there might be some race conditions, things might broke down, and there might be data inconsistencies. But this is a very simple app. We're not going to have multiple clients trying to modify the same data. So I don't think that's a problem that we need to worry, at least as of right now. So let us know if it's becoming a breaking change or like a breaking issue in the future, but don't worry about it right now. Okay, anything else? Go ahead. Hmm? The package? Oh yeah, sure. I'll leave it here just in case. Okay, if not, I think we can call it for this session. Thank you guys for coming in. Next week, we'll be covering backend integration and user authentication. And yeah, so if you want to learn more about that, if you want to learn more about how everything that we have built so far will work together, remember to come. And thanks for coming again, guys. And if we forgot to give you prizes, feel free to come up and pick your prize. We have a lot of them. All right. Okay. Prizes? Feel free to go. You don't have to. You can take multiple if you want.